Hi children, let's continue with few more examples of balancing chemical equations today. The first equation today is hydrogen plus chlorine gives HCl. It's a very easy equation. I hope all of you must have understood by now how to do it. There are two hydrogen atoms, two chlorine atoms on the reactant side and just one on the product side. So what should you do to make it the same? Just have to write a 2 there. So two hydrogen atoms, two chlorine atoms, two chlorine atoms, and it is balanced. Barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. Let's see. There's one barium here, one barium here. Sulfate, chlorine is 3 and chlorine is 2. Whenever there are numbers like 3 and 2 on the side of products and reactants, it is always best to make it 6. So this is 3 here and this is 2. So if I put a 2 here, it becomes 6. And the chlorine is 6 now. There are 6 chlorine atoms. On this side also, if I write a 3, it becomes 6 chlorine atoms. So chlorine 6 here, chlorine 6 here. It is balanced. Aluminum is 2, aluminum is 2. Sulfate is 1 here, sulfate is 3 here. So I write a 3. So that makes 3 barium, 3 barium. It's balanced. Barium is balanced. Sulfate is 3, sulfate is 3. It is also balanced. Aluminum 2, aluminum 2. So it is a completely balanced equation. Look at this here. Sodium 1, hydrogen 2, oxygen 1. Sodium 1, oxygen 1, hydrogen 1 plus 2, 3. So I will put a 2 here, it becomes 4. And I will put a 2 here, so that oxygen is 2 now, oxygen is 2. Hydrogen is 4, hydrogen is 2 here, and hydrogen is 2, 2 plus 2, 4. Sodium 2, so I have to make sodium 2 here. So it's a balanced equation now. Look at this equation. Sodium chloride plus silver nitrate giving silver chloride plus sodium nitrate. 1 sodium, balanced. 1 chlorine, balanced. Silver is 1. Nitrate is 1. So this need not have any coefficient. All of them are 1. So it's a completely balanced equation. Look at this. Barium 1, chlorine 2, hydrogen 2, sulfate I am taking as a radical together, not sulfur and oxygen separately. This will make it more easier. On this side you have barium 1, sulfate 1, hydrogen 1, chlorine 1. So both the hydrogen atom and chlorine atoms are 2 and 2. So I can put a 2 here. So hydrogen and chlorine are balanced. 2 chlorine, 2 hydrogen. Now barium is 1, sulfate is 1. So it's a completely balanced chemical equation. In order to make the chemical reaction more informative, you can specify the physical states also. Like if the reactant is in the gaseous form or solid form, you can mention it below the symbol like this. Carbon reacts with oxygen to form carbon dioxide. The carbon taken is in the solid form, so I can write an S here. If oxygen is in the gaseous form, oxygen is in the air, so I write a G. And carbon dioxide is again a gas, so I write G. So in order to make chemical equations more informative, we can specify the physical states of the reactants and products by writing it below the symbol of the reactant and the product. If the substance is solid, we write S. If the substance is liquid, we write L. If it is gas, we write G, within brackets all of it. And sometimes if the substance is in water, we write in aqueous solution. Also, we can specify the conditions of the reactions on the arrow mark. If reactant on this side and you have products on this side, you can specify the pressure, the temperature and the reaction conditions on the arrow or below the arrow. Like some reactions take place at 1 atmosphere pressure or some reaction takes place at 273 Kelvin. You can write it on the arrow mark or below the arrow mark. Some reactions require catalyst. Catalyst is any substance that enhances or increases the speed of a chemical reaction without itself undergoing any change. For example, for hydrogenation, you will need hydrogen in the presence of platinum or palladium. This is a catalyst. Photosynthesis, all of you must be knowing, needs chlorophyll in the presence of sunlight. So all this can be mentioned on the arrow mark, which connects the reactants and the products. That is how you get a completely balanced chemical equation, or a complete chemical equation. Along with the physical state and the reaction conditions give you a complete chemical equation. Let us move on to types of chemical reactions. There are few types of chemical reactions that you should know. The first one is combination reactions. From the name itself, you will understand that it's about combining. When two or more substances combine together to give a single substance, then you get a combination reaction. Understand? Two or more substances, they can be elements or compounds. They join together or combine together to give a single compound. This type of reaction is known as combination reaction. Let's see an example, a general example. We generally represent a combination reaction like this: A plus B combining to give C, where A and B can be elements or compounds, and they join or combine to give a single product, that is C. One example of this reaction is the reaction between quicklime and water. You take a beaker, add some calcium oxide, which is quicklime, or take some quicklime, not add water to it. Take calcium oxide in a beaker, add water to it, and what happens is calcium oxide reacts with water to give calcium hydroxide, and it liberates heat. Heat is given out. The new compound is slake lime. Calcium hydroxide is also called slake lime. So this is a combination reaction. Two substances are combining to give a single compound, and heat is liberated as a result of the reaction. Another example is coal. It is carbon in the solid form, reacts with oxygen, or you burn the coal and you get carbon dioxide gas. This is another example of combination reaction. Two reactants, one product. They combine to give you the product. Combination of hydrogen and oxygen to give water is again a reaction in which two reactants are combining to give one product. This is also a combination reaction. This reaction needs to be balanced. I should write a 2 here and a 2 here, then it becomes balanced. So these are all examples. So we discussed a reaction in which quicklime reacts with water to give you slake lime or calcium hydroxide. Calcium hydroxide is used for whitewashing of houses. What is done is calcium hydroxide is applied on the walls of the houses, and in 2 to 3 days it reacts with the carbon dioxide present in the atmosphere to form calcium carbonate. This calcium carbonate has a shiny appearance, so it gives a very good finish to the walls. It's interesting to note that calcium carbonate, CaCO3, is the same compound as marble or chalk powder. The chalk powder is also calcium carbonate and marble is also calcium carbonate. That's an interesting point to remember. Okay, that's all for today, children. See you in the next class.